Hello and welcome to Algebra Online. Today we're in section 511 and we're going to be talking about exponential growth. So today for our learning target, I want you to be able to represent exponential growth with a diagram, a table, and a graph equation. I also want you to recognize patterns of exponential growth. All right, so let's go ahead and start with our opener for today. If you notice, we have a proportion. See here, we have two fractions that are equal to each other. Our variable is in the denominator of the second fraction. So we would like to get this variable by itself. So for this proportion, what we can do is we can cross multiply, meaning I can take the 4 times the 3, which is 12, and I can set it equal to the 7 times the 2x, which is 14x. Then you guys know the next step. 14 is multiplying the x. So the opposite or the inverse is to divide by 14. And we have x is 12 over 14. And we can simplify that, right? We can take a half of the 12, which is 6, and we can take a half of the 14, which is 7, and we can say that the final answer is 6 over 7. All right, so what I'd like you to do is definitely pause this video and write down each slide before I talk. That's like the best strategy that I could really give you, I guess, is that way you have it all in your notes first before I talk. And like, that's what happens in the classroom, right? Your teacher pauses, gives you time, walks around, have you write this down in your notes, and then the discussion begins. So please make sure that you do that. All right, so the question is, how is this pattern growing? Well, let's take a look at what's happening with the x column. Each time it is increasing by 1. Good. And then for our y's, looks like each time it's increasing by 3. So the slope, right, of these points, the slope of the line that goes through those points, rise over run, it would be 3 over 1, which would be 3. And so this pattern is growing by 3 each time, and we can say that it goes up 3 and then to the right 1 if you're visualizing the graph in your head. So we know this is linear. This is linear because it is growing by a constant rate, right? It is growing by 3 over 1, or 3 each time. And so because it is linear, we can represent it in the form of y equals mx plus b, which is slope-intercept form. And we know that m is slope, so we have y equals 3x. The question becomes the b. The b is the y-intercept. Where does this line cross the y-axis at? On a graph, and it crosses it at 2. When x is 0, it's like our starting point, our y is 2. So it would be y equals 3x plus 2. So now we're going to shift gears, right? We're good at linear. We've reviewed over linear for quite a bit. Now we're going to talk about exponential growth, and what does that look like? So I'd like you to please take a minute and copy this down. Press pause right now in the video, and then let's press play. Okay, so Lenny and George, you guys remember Mice and Men? They started with 2 rabbits. Each month, those rabbits have 2 babies. So the question is, how many rabbits is there going to be after 4 months? Now, have you ever heard the term, like, isn't it like it's like growing like rabbits, multiplying like rabbits? It's just really, really quickly. And so we're going to see how that plays out. So let's go ahead and draw a diagram. Let's start off with our 2 rabbits. Those are not cute rabbits. They're circles, but we're going to pretend that they're rabbits. And these 2 rabbits, they're going to have 2 babies. And so that right there is month 1, right? Because each month they're going to additionally have 2 babies. So I'm going to write month 1. Then from there, this one has 2 babies and this one has 2 babies, and now we're at month 2. And then they keep going. 1, 2, 3, 4. Whoa, and this is month 3. And you can see what happens with month 4. So I'm just going to pause right now and kind of see what's happening. So let's go ahead and take with our table, let's take our x values as the months. So we're starting off with 1 month, 2 months, 3 months, and 4 months. And our Y value is going to be how many rabbits do we have? So for the first month, we started off with 2 rabbits. They had 2 babies, and so we had 4. And then from there, let's take a look at after the second month. 1, 2, 3, 4, 5, 6, 7, 8. So now they have 8. Let's go ahead and count again. So we know that these are all 8 rabbits. So we have 9, 10, 11, 12, 13, 14, 15, 16. Do you see a pattern that is happening with the Y values? Is it growing by a particular number? And because it's not linear, because it's exponential growth, we're going to look for a multiplier. And so 4 times 2 gives us 8. And is that the same case for each time? 8 times 2 is 16. Sure does. And if we kept going with our diagram that we're drawing, if we kept going, we would be counting, you guessed it, 32. Because 16 times 2 is 32. And so now let's go ahead and take a look at what this looks like in a equation form. Not y equals mx plus b, right? Because this is an exponential function, okay? And so definitely please pause me and write this down. A is going to give us, or is the initial value, what we start with. And then B is the multiplier, how it's growing. Notice the X is an exponent. Very cool. And we're going to see what that looks like with the Lenny and George problem. All right. So if you were thinking about the Lenny and George problem, what did we start off with? Like, what's our starting number? Well, we started off with 2, right? We started off with 2 rabbits in the very, very beginning. So if that's the case, I can say that y equals 2 because that's my initial value. I started with 2 bunnies or 2 rabbits. Then I'm going to multiply that by b. B is our multiplier. And we recognized that this pattern is growing by a multiple of 2. It's multiplying by 2 each time. So really it's 2 times 2 to the x power, and that x power is going to stay the same. So this equation represents the situation for this table and this diagram. Awesome. Okay, so now let's just go ahead and look at that in a table now. And so I'd love you to pause this. Please pause this and copy this down. And so if we had the x as months, we had 1, 2, 3, and 4. Let's take a look at what this looks like. We said that y equals 2 times 2 to the x power. So now to find our y, instead of drawing the diagram, we could just take the 1 and plug it in for x. So there you go. And then in solving for y, right, in solving for how many rabbits, we would say 2 times, or 2 to the first power is 2 times 2, and that gives us 4. All right, let's go ahead and do the second one. So we have y equals 2 times 2, and the x now is going to be squared. Now, order of operations tells us we're going to do the 2 squared first. So 2 squared is 4. 2 times 2 is 4. Times 2 is 8. All those 2's. Whew. Let's go ahead and plug in 3 for x now. So we have y equals 2 times 2 to now the third power. Now 2 to the third power is 8, and 8 times 2 is 16. Just remember our order of operations and exponents property comes before multiplication. All right, so now the last one, we have y equals 2 times 2 to the fourth power, and you guessed it, 32. Now there's another way that we could represent this problem, and that's with a graph. So let's just take a look at what it looks like in a graph. If we had, because it's not going to be a straight line, right? Think about what it would be. What would an exponential growth look like? And if it's not going to be a straight line, maybe it curves a little bit. How does that look? All right, so let's start off with our starting value. Our starting value was 2, right? So when we had 0, it was like 0 months, we had 2 rabbits that we started with. And then in the first month, we had 4 rabbits. And then in the second month, we had 8 total. The third month, we had 16 total. And the fourth month, we had 32, and that's just going to go way off our graph. So as you can see, it grows fast. Grows so fast, so quick. And welcome to exponential growth. All right. I'm going to take these next 2 slides and we're just going to review some concepts that we have already worked with, but it is going to show up in your homework today. And so I want to review with you evaluating functions and solving systems by substitution. All right, so if you know me, you know my strategy is, do you see one of them that is a y equals? Yes. The second equation says y equals. So we're going to circle everything that the y equals, and then we're going to take that and we're going to plug it in for y in the first equation. So now we have our new equation says negative 5x plus 8y, but instead of the y, what are we putting? We're putting parenthesis x minus 3 equals the negative 18. Good. So now we need to distribute the 8. So 8 times the x and 8 times negative 3. So negative 5x plus 8x minus 24 equals a negative 18. All right, so next, our whole goal is to get the x by itself. And when you look at the left side of the equation, you notice that we have like terms. So we want to combine these like terms first. And when we do that, negative 5x and a plus 8x is a positive 3x minus 24 equals a negative 18. All right, let's go ahead and add 24 to each side. And I'm running out of space, so I'm going to move myself over here. And now it's going to say 3x equals 6. And that's a positive 6 because we have the 24 minus the 18. And then when we divide by 3, we have x equals 2. All right, well, we know that a system, the solution to a system is a point on a graph, right? Where do these 2 equations, where do these 2 lines intersect at? So we have the x coordinate of 2. Now we're going to take the 2, plug it in for x in either equation, but the second one looks a little bit shorter, so let's do that. So we have y equals, we're going to take this 2, plug it in for x, 2 minus 3, so y is negative 1. Final answer, everybody. Final answer. The x is listed first, 2 comma negative 1, and that is the point where these 2 lines will intersect. They will cross. All right. Very last example review. Let's evaluate expressions. Absolutely. Let's do it. Okay. So notice the f of 0. That means that we're going to be taking 0 and we're going to plug it in for x. Don't plug it in here. Remember, that's just a fancy way to say y equals. It's just telling the reader that this is a function. It's a good working machine. So I'm going to say, well, I have 10 over 2 times the 0 minus 1. Now 2 times 0 is 0, so really it becomes 10 over negative 1, right? And then now the answer is negative 10. All right, let's do the next one. F of 1. So we're going to plug in 1 for x. So I have 10 over 2 times 1 minus 1, which is 10 over 2 minus 1, which is 10 over 1, which is 10. 10 divided by 1 is 10. Now, if you're feeling confident, pause my video, pause this video, and plug in 6 and see if you get the right answer. All right, let's see how you did. I'm going to take that 6 and plug it in, so it is 10 over 2 times the 6 minus 1, which is 10 over 12 minus 1. Ooh. And then it would be 10 over 11, right? 12 minus 1, 11. Yeah, and then you're done. You're done. There's nothing else we can do there. I mean, we could convert it to a decimal, but no, it's not so fun. All right, guys, I hope that you enjoyed today's lesson, and I will see you next time.